Many winemakers choose to seal their bottles with synthetic closures instead of natural cork from tree bark. This prevents cork taint, which happens when natural cork gets contaminated by the TCA molecule. Cork taint is completely harmless to humans, but spoils the taste of the wine. This engineered cork is entirely synthetic and therefore resistant to TCA contamination. It's made of a food-grade polyethylene foam core encased in elasticized polymer skin. Both materials contract to squeeze inside the bottleneck, but then regain their original shape to seal the opening. To make the foam core, they mix talc with pellets of low-density polyethylene, a pliable type of plastic. Then they add pellets of dark brown and beige colorant to mimic the wood grain look of natural cork. For each customer's order of corks, a computerized system automatically releases the right amount of each ingredient into an industrial blender. The blender feeds a specially designed dual extrusion machine. The machine melts the foam mix to a liquid state, then injects carbon dioxide. This produces bubbles which create the cellular structure of the foam. The liquid foam enters the machine's horizontal extruder, while elasticized polymer enters the machine's angled extruder. Both extruders squeeze their materials through the same shaping die, which outputs a continuous rod of skin-encased foam. The foam core immediately expands. The elastic skin stretches with it. A water bath cools the rod, halting this expansion at a specific diameter. Then, an underwater ultrasonic gauge measures the thickness of the outer skin to make sure it meets specifications. The rod exits the water bath and continues cooling and shrinking as it drip dries. A laser gauge then verifies that the rod is perfectly round and measures a specific diameter by this point. When any of the measuring gauges detects an area that doesn't meet specifications, that part of the rod is flagged in the system and is discarded at the end of the production line. The rod now enters the final cooling phase. It travels in several loops past nozzles spraying cold water. As the rod cools, it shrinks to its final size, a diameter of between 22 and 23 millimeters. It's designed to fit snugly inside the standard 18.5 millimeter bottle opening. They had to calculate exactly how wide to extrude the rod, so that after expansion, then shrinkage, it would end up at this precise diameter. The rod now enters a cutter. The blade is so sharp that a safety cover is mandatory. It's removed here only for the camera. The winery placing the order specifies the cork length. Air jets automatically blow off any corks cut from areas the measuring gauges flagged as being problematic. The cutter slices about 10 standard length corks per second. All the good corks land on the conveyor belt and travel to the end of the line, where computer sensors count them as they drop into a collection bin. Additional machines print on the winery's name and logo and lubricate the surface with silicone so the corks will glide in and out of the bottle with ease. The factory's on-site lab tests samples from every order. Sensory specialists sniff each cork and compare it to a control sample. There must be no discernible odor that might affect the aroma or flavor of the wine. If there is, the entire order of corks fails inspection. While natural cork is designed by Mother Nature, a synthetic cork manufacturer can engineer the closure to fit more or less snugly, according to the amount of air the particular wine needs to develop correctly.